Welcome to Sunday Night Physics with an unorganized university student. This week's quote of the week is less about physics and more about human nature. Isaac Asimov once said, "The law of conservation energy tells us we can't get something from nothing, but we refuse to believe it." The aim of this experiment was to provide quantitative evidence supporting the law of conservation of energy, which simply states that energy is neither created nor destroyed, but transformed from one form into another. As I suffer from pendulphobia, we could not incorporate pendulums into our experiment like everyone else was doing. We realized that if the potential energy equaled the kinetic energy, then we would have evidence that all the energy in the system was being converted from potential to kinetic. Thus, the energy was being conserved as a whole. To do this experiment, we used a tennis ball, an iPad with the physics app, and several rulers to record height. Before we set out to prove that energy is conserved, we first asked Siri what energy was. She gave us that energy is the capacity to do work. Through Johnny's deep knowledge of energy, which is not equivalent to power, we knew that there were multiple types of energies and therefore multiple ways of proving that energy is conserved. We chose to prove quantitatively that mechanical energy is conserved. This method was chosen partly due to my crippling fear of pendulums, and we also felt confident that it would provide definite proof. Mostly the pendulums, though. The method involves calculating the potential energy of a tennis ball at a certain height and compare this to the kinetic energy of the tennis ball at a certain depth. If these types of energies equaled each other, then we had indisputable evidence that energy is neither created nor destroyed, but simply converted from potential to kinetic. A pattern we've recognized so far in physics is that when you answer a question, it typically just leads to another question. So in this case, we had to ask ourselves, what is mechanical energy? The conservation of mechanical energy states that the sum of the potential and kinetic energy in a closed system remains constant. This means that as long as the only force in the system is a conservative force, such as gravity, then the mechanical energy is constant. Furthermore, this means that as the kinetic energy of an object increases, the potential energy of the object must proportionally decrease. Post-experiment, we noticed that the recorded kinetic energy was different to the hypothesized kinetic energy. We then deduced that there must be other forces present, the majority of them being friction and air resistance. One thing to be certain of in physics is uncertainty. To eliminate the height uncertainty, we used 3 different rulers which all measured the distance to be the same. The most impactful uncertainty measurement came from tracking the velocity of the ball. To track it, we had to place a dot where the ball was per frame given. However, in all of the frames, the ball became elongated and blurry, thus getting an accurate position of the ball in a given frame was plagued by uncertainty. This meant calculating an accurate average velocity to be highly unlikely. Since the kinetic energy equals 0.5 times mass times the velocity squared, an inaccurate measured average velocity would have been severely impactful in the overall kinetic energy recorded. We realized that the experiment we performed was in an open system with non-conservative forces present, these being friction and air resistance. If we combine these forces together in a group known as energy loss, then through algebraically arranging the equation potential energy equals kinetic energy plus energy loss, we gain that energy loss equals potential energy minus kinetic energy. When we sub in the values, we get the energy loss values shown below. However, we have to keep in mind that the average velocity was not accurately measured, and because of this, I suspect that the energy losses rate is very high and that these should be lower. Conclusion! Initially, we did not calculate the non-conservative forces, so upon realizing that the kinetic energy was not equal to the potential energy, knowing that energy can neither be created nor destroyed, it had to be transformed in one form to another. And so we realized that the kinetic energy was being transferred into heat via friction and air resistance. This means that the potential energy will always be greater than the kinetic energy, and that the potential energy will always be equal to the kinetic energy plus the energy loss. This displays quantitatively that energy is neither created nor destroyed, simply transformed into another form of energy, thus proving the laws of the conservation of energy.